Carbon accounting is a method to calculate the climate impact for everything. This could apply to the impact of all activities of a company. One could consider the individual production sites or include upstream and downstream impacts that are not caused by the company but still result from the company's activities. Carbon accounting is also done for complete countries to report emissions in the frame of the Kyoto Protocol or the Paris Agreement. But carbon accounting can also relate to product supply chains, where the carbon footprint is expressed per unit of product. For instance, a bottle of milk, a pair of shoes, or a liter of petrol. For all these different perspectives, there are different approaches to carbon accounting, but they are all based on the same underlying principles. Companies that voluntarily want to report on their carbon impact often use the so-called greenhouse gas protocol, which allows them to report their direct emissions, which are commonly known as Scope 1 emissions, but also emissions from the power they purchase, called Scope 2, while Scope 3 covers any emissions that take place in the upstream supply chains for their feedstocks, as well as emissions from the use of their products. The Scope 2 and 3 emissions of one company are in fact the Scope 1 emissions of others. And the Scope 1 emissions of all activities in a country should find their way in the national reporting. To understand the carbon footprint of products, we mainly use life cycle assessment, or LCA. This means that we count all the emissions that occur from the point where the feedstock is being produced until the product end of life. This is also called cradle to grave, or in the case of fuels, well to wheel. As you will see in this overview, different LCA methodologies exist, depending on the purpose. The International Organization for Standardization, ISO, provides a detailed approach, including guidelines to data collection and stakeholder engagement, but leaves many choices open, so that the results are not always the same for the same product. Most of the other methods are more precise and reduce the free choices in the analysis. Stricter methods allow for a better mutual comparison between products and more uniform reporting. For example, the EU Renewable Energy Directive includes a detailed methodology to calculate the life cycle emissions of renewable fuels in comparison with the fossil fuels they replace. Here you see that a renewable fuel reduces emissions compared to fossil when compared over its life cycle. This method is part of the legislation. Renewable fuels in the EU market are required to achieve significant CO2 savings compared to fossil fuels. In the future, a fuel that achieves a higher emission reduction could have a higher economic value, as it will contribute more to the greenhouse gas intensity reduction target. The methodology is spelled out in the directive. It contains many aspects. Let's focus on a few of them. Overall, the life cycle emission is calculated by adding up the emissions from all activities and other sources along the supply chain. In biofuel supply chains, emissions especially occur in production of the feedstock in agriculture and in the conversion facility. When waste or residues are used, the emissions from feedstock production naturally become zero or close to zero. The results are expressed in grams CO2 equivalent per megajoule. The megajoule is the functional unit to make the results comparable. The gram CO2 equivalent is a measure for the climate impact. Also, savings can occur by carbon storage in trees or agricultural soil, or by carbon capture in the conversion step. Note that the CO2 that is emitted to the atmosphere during combustion is treated as zero emission. This is because it is equal to the CO2 that was absorbed at the beginning of the supply chain, when the crops were grown. All the carbon in the supply chain stems from atmospheric CO2, and therefore any biogenic CO2 emissions are never larger than the initial uptake, so they are climate neutral. Besides CO2, several other gases also have a climate impact, such as methane, CH4, and nitrous oxide, N2O, and these are strong greenhouse gases. Their impact is expressed in CO2 equivalents. For instance, 1 gram of methane has the same impact as 23 grams of CO2. CO2 is mainly emitted during the combustion of fossil fuels. N2O emissions in biofuel supply chains mainly take place during application of synthetic fertilizer. And CH4 emissions mainly stem from cattle and their manure or from rotting plant matter, for instance in wetlands. To calculate the carbon footprint, we take inventory of all the mass flows and energy inputs that occur at each point in the supply chain. For each of these inputs, we can use standard values to understand what emissions were caused in production and use of those inputs. For instance, both the production of fertilizer and its application on land lead to N2O emissions. The accounting of carbon emissions can be quite straightforward if one has enough data of the supply chain and if one knows the carbon impact of all the materials and energy carriers that are used along the supply chain. The results then look like this. Here you see that biodiesel on basis of used cooking oil has a supply chain emission of 11 gram per megajoule. The impact of renewable fuels is compared to that of a fossil comparator, which has been set by the directive to 94 gram CO2 equivalent per megajoule. Therefore, using this waste-based biodiesel in a vehicle saves 88% of emissions compared to using fossil diesel. To demonstrate compliance with the requirements of the directive, companies use proofs of sustainability. The greenhouse gas emission reduction score is printed on these proofs of sustainability. These are used in the European renewable fuels trade. We see that over time, companies gradually improve the CO2 performance. They do so by more efficient fertilizer application, smart agriculture, improvements in the conversion processes, or the use of renewable energy in the supply chain. As you can see, the biofuels industry is improving every year. Germany is moving faster than other markets as it is incentivizing the best performing pathways. Industry is responding to this by implementing the measures that I just mentioned.